Today we'll have some music theory shower thoughts on what the number of scales has to do with rabbits. Musical modes such as major, natural minor, Dorian, Phrygian and so on are very useful tools when it comes to composing or improvising. But the other day in the shower I asked myself a simple question. How many modes are there? If you perform a quick Google search, you'll quickly see that the common sense is that there are only 7 modes, one on each note of the major scale. If you take C major, this would be the major mode, and if you play on this major scale but starting with a different root note, such as here D, you get a mode of the scale, here the Dorian mode. However, it fails to count many different ways to go up the scale. So you may be perfectly happy with these modes and still improvise in these. For instance, we could take the Dorian mode and do a little improvisation. But you might want many different ways of going up the scale. For instance, what about this way? This is certainly a bit strange, and you'll even notice that it has more notes than the normal scale, so it cannot be a mode of the major scale. You might say, what a strange way to go up the scale. Why would I need to do something like this? Well, what if you want to improvise something more like this? So this raises the question, just how many ways do you have of going up the octave? This is exactly the question we'll answer in this video, and funnily enough, in the shower I thought, well, you know what, this has a direct connection with the number of rabbits. Before we delve into it, we have to define the boundaries. We will call a scale a way to go from this C to this C. You'll see that it's not very important that we use C, because if we used another note, well, it's all semitones up, so we can directly translate a scale from C to C to a scale from any note to any other note. We'll also limit ourselves to using either full tones or semitones in our scales. So we're going to count the number of ways to go from this C to this C using tones and semitones. This is a slight limitation because you might want to consider scales such as this one that starts with a bigger interval, you know, here a minor third. However, clearly all such ways of going up the scales are also embedded in a way which is slightly more refined. So here you could start with or. Okay, let's actually get to counting now. Our problem is counting the number of different scales from this C to this C. Now, what if we instead asked a simpler question, which is how many scales do we have from this C to this G? Or even simpler, from this C to this E. Surely, if we go less far, there are less scales, and so it will be simpler to count them. But we can even make this completely trivial. What if we asked the question, how many scales are there between this C and this C? How many ways containing tones and semitones do we have to go from here to here? Well, exactly one. The one where you just play this C. You go from here to here. So there is one way to do so. Now, how many ways is there to go from this place to this place? Again, this is one semitone, so there's only one possible way, one possible scale, which is to go up the semitone. The question becomes a little bit more complicated when we consider to go from here to here, because now we can go by the tone or by two semitones. So let's write down properly what we've been doing. We are asking the question with our first note of the scale to be this C here. How many scales are there to go from here to this target there, this C here? Well, as we've just said, we can easily count how many scales there are to go from here to here. Similarly, we can easily count how many scales to go from here to this here, sharp note. We're going to call the number of scales which ends here, starting from this C, S1, because it's on the first note. We're going to call the number of scales that ends here S2. And you get the idea here. This one will be S3 and so on. And which number are we interested in? Well, it's very simple. This is S1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we are interested in knowing the value of S13. Now, well, we've just seen at the moment that S1, the number of scale that starts on the C and ends on the C, is equal to 1. Trivial. The number S2 is equal to 1 as well, because we can go up only the semitone. Now, what is S3? And here is the important idea. The idea is to say, if we go to this note, and we have used tones and semitones only, well, we can finish by either going up a tone or going up a semitone. If we go up a tone, it means that we had previously gone up to the tone before this end note. So here, the C. And if we went up a semitone, it means that previously we went up the semitone down. And so you'll see that any way that we come here, we must have first gotten either here or here. Which means that the number of ways to go here from this C is exactly the number of ways to go from this root note to this note, plus the number of ways to go from this note to this note. So we can write S3 is equal to, well, S1 plus S2, which is equal to 2. And indeed, this is correct. We can go like this or like this. Well, what is this S4? Exactly the same. We can go up a semitone to finish or a full tone. If we go a full tone, we need to go here previously, which means that we will exactly have S2 scales. And if we go here and up a semitone, we will have exactly S3 scales. So the number of ways to go up to this note from the C is, we can write S4 is equal to S3 plus S2, which is 3. And in general, we can do this for any note of the scale, and we can write this generally by saying that Sn is equal to Sn minus 1 plus Sn minus 2. And if you remember math class, this numbers 1, 1, 2, 3, the next one would be 5, then it would be 8. These are called the Fibonacci numbers, Fn, or n plus or minus 1, depending on how you define them. So now we can actually easily calculate the answer to our question, how many ways to go up from this C to this C using only tones and semitones. Well, we can know that S13 is equal to the strange number 233 different ways. And so that is our answer. And the connection to Fibonacci numbers is exactly how the number of scales is related to rabbits. Fibonacci introduced the so-called Fibonacci sequence in his book Liberabaci in 1202, where it was used to model the growth of a population of rabbitses. Yes, I say rabbitses, it's like hobbitses. Sorry, I've been filming this for way too long. Here's the page of the book, where sadly no rabbits are drawn, but you do find the same sequence drawn with strange numbers, but the same sequence, and 233 in the 13th position on the right. Hopefully you found those little shower thoughts at least a little bit intriguing, and if you want to see either more or less of them, please like, dislike, unsubscribe or subscribe correspondingly. But you know the drill.